Alright, so we're going to use Python again a little bit here to sort of illustrate what we mean by a function, and just, as more of a general concept. We're not going to do anything crazy like we did before, because I don't know, I kind of felt like that got out of control. But so I'm going to write some Python code up here, and it's not standard or not on a syntactical level. It's only important that the concepts are being demonstrated and illustrated, more importantly. So let's jump into it here. How can we explain more specifically? How can we demonstrate why functions are needed, or what advantage does it give us? So let's say you have a variable. We'll just make it 10 because that's an easy number. Let me think about this here real quick. All right, so let's say we want to divide x by 2. We could just say x divided by 2. Python says, yep, you got 5. Let's say we have another variable, we'll call it 20. Or we'll call it y, we'll give it a value of 20. What's y divided by 2? It's 10. Let's make another variable, we'll make it 50. We'll divide z by 2. So what we've done is we've made 3 variables with 3 distinct values, and we've done the same operation, the same division operation on them by typing, by substituting the name of the variable into the operation. The operation is the same. The only thing that's different is the name of the variable. So in this extremely contrived example, let's ask ourselves a basic question. Wouldn't it be awesome if we could just have a way to tell Python, without actually having to really specify the variable, apply divide by 2 to whatever it is that I'm going to give you? So this is sort of the rough idea of a function. This is extremely simplistic, but a factorial is sort of the more quintessential example, but I'm trying to keep it extremely simple here. So let's write a basic function in Python that's going to apply the operation of divide by 2 to whatever you give it. So we will just say def divide by 2, some value. Oops, I hope that didn't mess it up. Return some value divided by 2. We'll put parentheses around it because why not? Alright, so it's not important what that means, or it's not important about def and return and all that crap, but basically what this means now is that we can essentially call this function, which we named divide by 2, we can give it some value, and it will return some value divided by 2. So we can prove that. Say divide by 2, x. We get 5. So let's say divide by 2, y. And then we'll say divide by 2, z. There you go. This is an extremely ridiculously contrived example. Okay, let me stop here. Getting some stuff from him. Some test cases. He's doing a whole lot of stuff. Son of a bitch. I really don't want to stop this. Am I going to have to close Steam? Am I going to have to be an asshole? I'm going to have to, yeah. Sorry, Fuggles. So anyway, he's having some programming problems right now, and he's trying to tell me some things about it, and some ridiculous stuff. That's what I'm gonna say. So anyway, getting back to where we were, or what we were talking about, is divide by 2 is sort of we named the function divide by 2. We can give it some value, and then we can encode in that function whatever instructions we want. It doesn't just it doesn't have to be as simple as some value divided by 2. We could make that function as big as we want, and then we could have that function call other functions and whatnot. And so you can see that it's all sort of daisy chained together relative to Cheat Engine. What we were doing in the previous video is we were selecting the current function as it was represented by assembly instructions, and then you could see sort of with our daisy chain example here that let's say that we were looking at the assembly instructions for divide by 2. what if divide by 2 called some other function like divide by 1 or divide by 3? It's not important conceptually why it would do that, but let's just say it did. You could see how you could get into a scenario when you start digging through assembly instructions that provide no real context whatsoever as relative to their surrounding code, that you select a current function, and then there's another function that it calls and another function that it calls, and you could just quickly sort of find yourself hopping all around in memory looking at all kinds of different functions, and it gets pretty confusing pretty quick. But again, for our purposes here, you can define functions. You can see that conceptually what a function is it's sort of a canned series of instructions that you can apply to any random value. And it doesn't have to just be a variable. We'll hit enter here a couple times. You can say divide by 2. You can just pass it a literal value, 10. It's just, I don't even care. Oh, okay, it's 5. Let's do divide by 2. Shut up. Divide by 2. We'll give it 100. It's 50. We'll write another function here real quick. Let's say def squared. I don't want to call it that because that function it does not exist. So we'll just say squared a value, or we'll call it another value. Say return some expression. What is that expression? It's going to be another value times itself. So what is x squared? It's going to be 100. So there you go. Squared y, it's 400. Squared z, 2500. And again, it doesn't have to be a variable. You could square anything you want. Pretty much any number that you pass in, it's just going to say, yep, let's square 0, 0. So again, conceptually, a function is a canned or is a series of instructions that is associated with a single name. So instead of having to write the same code over and over and over and over in your program, all you have to do is define a function, some parameters or parameter that it takes, and then some series of instructions that operate on the parameters that are passed into that function. And whatever is passed into that function cannot be known when you're writing the code. It's known when you execute the program and the instructions and the parameters are actually passed in. So obviously when we were writing this squared function, we didn't have to pass in x or y or z or 100 or 0. We were simply defining in a very generic way what we want to do with whatever value gets passed in. And let's try and, so we're going to close this now. Let's see if we can maybe bring this back full circle a little bit. I'm going to have to start up Steam in order for this game to launch, so I may get a whole lot of messages. Let's open up Cheat Engine here again. Yep. Doesn't matter. Just go to that. Just open up the memory viewer. Does it bring us to something? Yeah, alright. Well, crap. I guess we're going to have to. Before. Alright, so we have the values. Right click on it, find out what writes to the address. Yep. And we do that. We click that. We have one hit. That's great. We click on it. We could say show this address in the dissembler, or we can just click on it and go over here and say show dissembler, which is what we're going to do. So we were right clicking on whatever instruction we were sort of jumping at or evaluate or looking at, and then we were saying select current function. And what Cheat Engine is telling you is, in the larger context, this is the assembly instructions that make up the function that was defined, that is defined in the game, so that you know sort of in a general way what the boundaries are for screwing around with whatever the function is that gets called when you click plus. Because if Cheat Engine didn't have this I mean, you can say rat is return and stuff like that, but Cheat Engine makes it real easy for you and says, here's the instructions that sort of make up the playground, if you will, for you when you are messing around with whatever value you're looking for or trying to mess with. And messing around with stuff outside these selected function or these selected instructions is generally not really going to help you out when it comes to manipulating this value. Now again, there's functions that call functions that call functions, and the function that's highlighted right now is probably called by some other function and some other function whenever you click plus. And you could there are ways where you can daisy chain that, or sort of bubble back up and dig through that hierarchy. That's not something we're going to really do right now, but again, this is so. I mean, if you find the actual assembly, and so why is this important? If you find an assembly instruction, and let's close this and see if Cheat Engine will jump us right back to it. It will. So let's say you find assembly instruction. You say, show me that spot in the disassembler, and then you go there, and for whatever reason, you're knopping it out, or you're trying to actually do like like overwrite it in some specific way, not just a knot, but you're just overwriting it with an instruction that you're writing. Say you can't get the desired effects, or instead of manipulating this instruction directly, you want to maybe mess with EAX before this instruction is executed. This is how you know what you can mess with and what you can't. Cheat Engine will say, here's the whole function, and even if generally it's not required to look at the whole function. More often than not, what you'll do is maybe go like, a couple lines up, couple lines down, and once you understand assembly a little bit, you'll have sort of a basic idea of like, okay, so this is what this instruction is doing, is it's moving the new value of the karma on the screen or in the character creation screen into ESI plus E0. So, what can we deduce from that? Well, ESI plus E0 is obviously this value right here. Whenever you move something into ESI plus E0, such as whatever the value of EAX is, or the register EAX, this value changes. So in a more advanced way, and this is what we're starting to get into, is an easier, or maybe not an easier way, but what you can do is you can just say, well, what is ESI plus E0? Well, it's maybe some structure in memory that stores all kinds of great values about the player and or whatever the object that you're examining is. And E0 is the offset, so ESI is probably where that structure starts. So you can sort of use some tools that Cheat Engine provides, and you can say, all right, well, I want to sort of examine the structure that starts at this address, and Cheat Engine makes it fairly easy for you to do that, and that's sort of the essence of the structure dissector in a nutshell. And that's we're moving in that direction, but in the context of functions, it's never just one simple instruction. This instruction only has meaning relative to the surrounding code, not just above it, but also below it, because of what we just talked about. This instruction is part of a function, and that function, the entire function, its purpose is to manipulate this value. So is it all the logic of manipulating this value in this one function? No, or maybe. There's no way for us to know at this point, because again, maybe it's called by another function, maybe this function calls another function, so on and so forth. So again, just to sort of do a summary of a theme, or to bring a theme back up that we've been talking about a lot, it's never cut and dry when you get into this stuff, because you're looking at assembly code relative to higher level functions, just like we defined in Python. That Python makes it very easy for us to say, hey, there's a function, there's a name, here's the operation I want you to apply, done deal. It's, as you can see by looking at assembly, there is no such facilities for making it as cut and dry as that. So maybe we'll talk more about functions if we have to, but I'm hoping that we have a general conceptual idea of what a function is and why it's important to not just look at a single instruction, but look at the instructions around it. And we'll pick up, obviously, as I like to say, we will pick this up more, maybe not this specific topic, but we will pick up the series in the next video.